Salam sejahtera dokter. So our group is group 2, and for task 1, given that the x1t is a triangle signal and the x2t is a rectangular signal, so we write them into a unit step function. So given that the zt is the addition of both signals, so the zt is equal to x1t plus x2t. So for t is greater or equal than 1 but less than 0, the zt is equal to 1. And for t is greater than 0 but less than 1, so the zt is equal to 2t plus 1. And for what t is greater than 1 but less than 2, the zt is equal to negative 2t plus 4. So we combining the result of zt at the different range of t, so we get this value. So this is the shape of graph of zt.
Hi, I'm Chichong from Group 2. In this video, I'm going to explain the convolution part of task 1. In this task, we are asked to find yt, where yt equals the convolution of x1t and x2t. And here's the formula for the convolution. According to the formula, the first step we need to do is to find out x1 tau and x2 t minus tau. Next, we calculate the integral of the product of x1 tau and x2 t minus tau. However, to get a complete expression of yt, we have to evaluate the integral of all values of t in order to consider the different cases of overlapping between the signals. Thus, we divide the time into a few different ranges. First, when t is less than -1, the signals do not overlap, so the product is 0, and yt equals to 0. When t is in the range of -1 to 0, the signals overlaps from tau equals to 0 to tau equals to t plus 1. The results of convolution in this range is t squared plus 2t plus 1. Then we repeat these steps for other ranges of t, namely from 0 to 1, from 1 to 2, from 2 to 3, and also for t greater than 3. After considering all the values of t, we combine the results to get a complete expression of yt. Finally, the results are plotted using Desmos to visualize the final results of yt. That's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Azizi Ashraf bin Riza, and I would like to explain to you guys about the assignment convolution and the MATLAB coding. So for the first step is to define time in triangular signal. So we set time is 0 until 2 in 0.01 sample. So this one is the function of triangular signal. So we define also for the rectangular signal, we set -2 until 2, we sample 0.01 for the time range, and this one is the equation of rectangular signal. So to make the graph tally, between rectangular and triangle, we set t common -2 until 3. So the graph basically same with -2 until 3. So this one we interpolate x1, interpolate t1, x1, t common, linear, and 0. Same for the x2. So for the addition of signal, the equation is z equal to x1 plus x2, and this one is function of convolution of two signal. So for the last step is to make the plot for the graph triangle, rectangular, addition, and convolution. So for the first, we plot the graph for triangular signal, and we arrange in the subplot and triangular signal, rectangular signal, and addition signal, and the last one is convolution of signal. So for the result is this one: triangular signal, rectangular signal, And the new coding is addition of signal. And for the last one is convolution of two signal. That's all from me. Thank you.
Here, Task2, it is given the input signal is Ft, while Ht is the signal of the LTI system. To find the output of Yt, it is the convolution of Ft star with Ht. So we will use this formula to find Yt. Well, first we need to convert this signal of Ft to F tau, while this Ht to Ht minus tau. And then integrate with respect to tau from negative infinite to infinite to find Yt. So in this case, we use multiple of interval to find and analyze between the two signals where it going to intersect or overlap with each other. So we first, when t less than 0, so we can see here there's no overlapping. So yt is 0. But for t between 0 to 1, there is overlapping between the two signals from 0 to t. So we integrate as usual with respect to tau, so we get yt here. And then next t between 1 to 1.5, there is an overlapping from 0 to 1 here inside. And then we will get yt is 15 over pi. Next t between 1.5 to 2, there is overlapping also. As integrate as usual with respect to tau, we get yt. And for t between 2 to 2.5, as you can see, there will be two part will be overlapping here. So there will be two integration from 0 to t minus 2 and from t minus 1.5 to 1 here and here. And then we get yt here. And for 2.5 to 3, there is overlapping here. So integrate as usual with the lower limit here to the upper limit here. So we find yt. Next, for t between 3 to 3.5, the overlapping only here. So it is from t minus 2.5 to 1. And we will get yt when we integrate as usual. And when t more than 3.5, there will be no overlapping, so yt is 0. So we can conclude, combining all the result of the integration that we use to find yt for each interval, so we can get this yt. So we are demonstrating the convolution, the result of the convolution between the ft and ht. We use Desmos. So as you can see, this is the graph.
Now, I will present to you the MATLAB code for task 2. First, we define the time vector that span from -5 to 5 seconds with step size 0.01. Then, we define the unit step function, ut. After that, we define the input signal ft, which is can get from 5 sin pi t multiplied by ut minus 1. Then, we define the impulse response ht, which is have positive impulse 1.5 from t equal to 0 until t equal to 1.5, followed by negative impulse at t equal to 2 until t equal to 2.5. Then we do the convolution of ft and the ht to get the output signal yt using the convolution function. Then for this part is for the plot the result. As you can see, for the first part is to illustrate the graph of the input signal ft. For this part is for the impulse response ht, and for this part is the output signal yt, which is the convolution of input signal ft and impulse response ht. For all of this graph, the x level is represent a time in second, while y level is represent the amplitude. Now, this is the graph for the input signal ft, and this is the impulse response ht. And this is the graph for the output signal yt, which is the convolution of ft and ht. What we can observe from this is the graph have the same shape with the manual calculation. I think that is all from us. Thank you.